Hey guys, our next problem is on the band brake. So the question is, a band brake acts on the 3 by 4th circumference of the drum of 450 mm diameter, which is keyed to the shaft. The band brake provides a braking torque of 225 Newton meter. One end of the band is attached to a fulcrum pin of the lever and the other end to a pin 100 mm from the fulcrum, and mu equals to, that is friction, that is 0.25. Find the operating force when the drum rotates in anticlockwise and clockwise direction. So let us first write the data. Here the data is, so first of all we have given the diameter of the drum, that is d equals to 450 mm, that is 0 point into 10 to minus 3, that is 0.45 meter. Now the next is give, that is, therefore the radius would be 450 by 2, that is d by 2, that is 0.225 meter. So the next, the band brake provides a braking torque of 225 Newton meter, that is braking torque, that is TB equals to 225 Newton meter. The next is friction, that is coefficient of friction, that is mu 0.25, and the other, and the angle, that is 3 by 4th. So the total circumferential angle covered by the band is theta equals to 3 by 4 into 360 degree. So this will become 270 degree, and now converting into radians, that is pi by 180, we get 270 into pi by 180 equals to 4.7 radians. So there are two different cases. The first case is for the clockwise rotation of drum, and the second will be anti-clockwise rotation of the drum. So drawing the corresponding diagram, here it is a drum with center and the contact surface, that is 270 degree as per the question. So here it is a diagram representation. So here it is the rod, which when application of the force is going to stop the drum rotation, which is in clockwise. Here there are two tensions, T1, tension T1, T2. Now the distance, here the distance is 100 mm, and from here total here length is 500 mm. And here the force acting is P from the C. Here it is the fulcrum point O and the B. So this is the band which covers the drum externally. So now, as per the conditions of limiting tension ratio, we can write limiting tension ratio that is T1 by T2 equals to e raised to mu theta, that is e raised to mu theta, where mu coefficient of friction, that is 0.25, and theta we know that is 4.7 radians. 4.7. Now that is equals to T1 equals, solving this we get T1 equals to 3.24 T2. So this is the T1 value. Now since we know the braking torque, now braking torque can be written as Tb equals to T1 minus T2 into R. Since we know that braking torque equals to 225 and R equals to 0.225, from previous equation T1 equals to 3.248 T2. So solving this we can get the value for the T2, that is 444.8 Newton, and also T1 equals to 1444.75 Newton. So this is the value of T2 and T1. Now we need to take moment along fulcrum O. So from the diagram we can see P into L minus T1 into B equals to 0. Therefore P equals to T1B upon L. That since we know the value, all the values T1B and L, just putting them to 0.1 upon 0.5. So we take the values 288.9 Newton. So this was the first condition. Now we need to solve for the second conditions. So second condition is anti-clockwise. So we need to solve for the anti-clockwise direction. Drum rotation. So let me draw the diagram for it also. So in this anti-clockwise direction, taking moment about O, that is fulcrum, we get P into the whole distance L minus T2, here that is tension T1 and T2 both acting downward, T2 into the distance that is 100, that is you can write as B also, equals to 0. So now we need to find P, that is taking their right side, T2 into B upon L. So we know all the values, just placing them, 444 into, that is B, that is 0.1 meter upon L, that is 500, that is 5. So the answer is 88.9 Newton. So this is the P, force required to stop the brake or drum completely.